Hello all, welcome to today's video. Today we are going to look at input and output in Python. How do we provide an input to the Python program and how do we receive the output from the Python program? We will go ahead and see the syntax and all the different methods in which inputs can be provided into the Python code and outputs can be received from the Python code. Let us get into the video. Input functions. How do we provide an input to a Python code? So input can be provided using the input function. This input function waits for the user to provide an input which is stored in a variable that can be used throughout the program, performed operations, and then we receive an output. This data that we give through the input function is always in a string format in Python. So what if we want to give inputs that are of different other data types? In the upcoming slides, we will see how the type conversion is done. We can provide an input which the Python takes in as a string, but this can later be changed to a different data type. So here, let us see an example of how the input function works. The input function here is taking the value for the variable name. It prints enter your name and waits for you to provide your name. This is then taken as a string and stored in the variable name. Then it executes the next line of code. In this line of code, the input function is asking us to enter an age. Even if we enter a numerical value, for example, we enter a numerical value 15. This is taken in as a string. So how does this value be identified as a numeric value? For this, we need to do the type conversion. We will look at how type conversion is done. Conversion of an input. The input always takes in a string formatted input. So in case of the previous statement that we saw, where we tried to input a age variable, we saw that it took it in the format of a string. The 15 is taken in as a string. So to convert it to the integer data type that it is, we use the type conversion. How do we do the type conversion? When we take in the input, when we say enter your age, it is then put into the int function which converts into the integer form, which converts the string into an integer format. Now, if we see, the age will be 15. This is an int data type, whereas this was a string data type. Output operations. How do we perform output operations? We use the print function. So print function is used for displaying an output in the console. It can print strings, variables, expressions, or even formatted output. Here we see an example where we are trying to print a statement, a string that is hello world. So when we use the print function, it prints this as an output. Let us try and format the output statement. So when we saw in the previous slide, it just says print hello world. Hello world is very static. It will directly print hello world into the output console. But what if there is a variable that needs to be incorporated into the output? And this variable may change into any value in the given course of the program. In those cases, we might not know what will be the output. So when we want to incorporate a variable that has some value and we want to print that value, what we do is we format the print statement in such a way that even though the variable may change into multiple values throughout the program, it will produce the last value that has been given to that particular variable into the output. Here we see in this example where we use Alice is the value for the variable name, and we have 30 that is the value for the variable age. We want to output the name and the age, which is Alice and 30. We use the format function which allows us to provide to get an output that will incorporate these variables in it. For that, we have the syntax print open braces, we give name and the braces, and then we have the age, we have the braces. So anything that is given between the double quotes over here is printed as it is. Now we use the format function, which allows us to get the values of name and age and print it as an output. So what will be the output for this? The output will be name colon Alice and then comma age colon 30. Even though the name and age variables might have different values throughout the program, the end value is now incorporated into the output. See, we can also use F strings. These are called formatted string literals. In any Python version that is above 3.6, we use the F strings. This is another syntax where we try to get the name colon. Instead of using the format function, we directly incorporate the value name over here, Alice, and then we have the age, that is 30. This is because we have this F string over here. This F string allows us to incorporate all the variables values into the output statement. File input and output. So far what we have seen is that input and output statements that can be entered via the console and that can be outputted via the console. Suppose we want to input a file. In that case, for file input and output, we use two other functions. First, let us see how we can read from the file. We use the function open to first open the file for reading, and then we use the read method that allows us to see what are all the contents in the file. So when we give it in R mode, it means it is in the read mode. So this is how we read from a file using the Python program. Here we see the syntax of how we can read from the file. We use with open. We are trying to open the file and we mention what is the file name. It is file.txt. And in what mode are we trying to read the file? It is in read mode, which means that we will not be able to write anything. We will be able to see what is there in the file as file, and then we provide all the data in the read, like all the data in the file.txt in the read mode into the variable content. File.read reads the whole file, the file.txt, and it stores it in the variable content. Next, we try to write to the file. When we try to write to the file must be open. So we use open to open the file for writing. To write, we use the mode W. W is for writing. The write mode writes data into the file. Here, as an example, we see with open, we are trying to open, the file is file.txt. In write mode as file, where in file we write some text. This write function allows to fill the file with the text or content that is given between the braces. So in the previous slides, we saw how to receive an input through the console and how to receive an output from the console. We also saw how to read from a file and how to write to a file. Now we see how we can receive an input from the file and how we can receive an output and send it over to a file. For this, we use the standard operations of input and output. So we use sys.stdin for standard input, sys.stdout for standard output, and sys.stderror for standard error. This takes in all the details from the file and provides us as an input to the program. And then when the program provides us an output, all this output is then sent to the file using the standard out. In case of error, it uses the standard error stream. So now we see how we read input into a file. When we use the standard input, it redirects the input console to read from the file that we have provided. With import sys, we use the standard input output stream to read from the file. With open, we are trying to open the text file input.txt in read mode as file, and this file is then provided as a standard input. We can also provide input using a user input by using the input function that we have already seen is a method where we can input through a console. Next, we see how we can automate the input for testing. Here, while testing, there might be multiple test options that you want to test on. In those cases, we can give all the input in a file and make sure that it is all automated to test every single scenario. Here, importing sys, what we do is we open the test underscore input.txt in read mode, and then we use the sys.stdin to input all the values in the test as inputs to check the whole program. How do we redirect the output to a file? We use the sys.stdout, which allows for directly outputting any value not into the console but into a file that we have mentioned. We use import sys. We open the output.txt. This is the file in which the output will be stored, and it will be opened in a write mode as file. What we try to do is in file, we try to print the value as this is the output. It is now going into the file, the output.txt instead of the console using sys.stdout. In the code, we saw that the output was directly getting sent to the file instead of getting captured in the system. So what is the advantage if it gets captured in the system? When it gets captured in the system, this output can also further be processed instead of directly writing it to the file and then retrieving it from the file. So to do that, what we do is we capture the whole data and process the data in a script rather than displaying it. How do we do that? Here in this example, we see that we import sys. We use the standard out to output the data that we have received as an output. Here we initialize a list. This list is output list. This list is now will capture all the output data. So we redirect the output to the list, that is s.stdout is equals to output, and this won't display, but it is captured in output. Even though we print it in output, it will not be outputted, but it will be captured. Now we reset the standard out to the original stream, which is sys.standard. So this is how we capture the data in the scripting format that can be later used in the code. Next, we look at standard error. Standard error stream is used for logging errors. We want error messages to be displayed when the output does not have any particular value and it is ended up in an error. So for that, we log all these error messages in a separate file. So let us look at an example for that. We see that we import sys, which is the standard error stream. We open a new txt file where it is going to log all the errors, and we use the sys.stderror to log into that file all the error messages. We also use print where we print that the error has occurred to ensure that the user knows that there has been an error in the program and that there has been no output that has been generated. To see what the error is, he can go into the error.txt file that will capture all the different error messages that has occurred in the system. Differentiating error output. Even though the error messages are a kind of output, it is very crucial to differentiate an error output to a correct output. In that cases, we use the standard error string. This will enable to redirect it to an error file which captures all the error details regarding that particular program. Reading and writing of binary files. Why is reading and writing of binary files so important? Not all data is textual data. Earlier in the previous examples, we see that all of the files that we saw are of the format .txt. What if we want to read a file that does not have a txt data? Suppose it is an image data. So usually while processing data, when we come across files that are not really textual data, we use the binary file method. Here we are reading the binary file with open. We are opening a particular image.jpg. This is an image file. We read it using RB, that is reading through binary, as a binary file, and then this is now stored into the image data. This image data is a variable that stores the data that is read in a binary formatted file. These methods allow you to handle a wide range of input and output scenarios in Python, from simple console interactions to working with files and binary data and system streams. That's all for today's video. If you really like it, go ahead and click the like button. If you have any doubts, put it in the comments, share it with your friends, and to watch more such videos, subscribe to our channel Data Pulsar. Thank you. Bye.